Hello everyone, in this video we will derive the expression for the radius of orbit. Now, according to Bohr model of an atom, in the center there is nucleus is present, around which electron is revolving in a fixed path known as orbit. So in this video we will calculate the radius of this orbit here. For this we considering that there is an electron of mass m and the charge on that electron is E, and it is revolving around the nucleus with a tangential velocity v, and we are considering that this electron is experiencing the electrostatic force of attraction. अब अगर सेंटर में न्यूक्लियस है और इलेक्ट्रॉन रिवॉल्व कर रहा है तो इलेक्ट्रॉन और न्यूक्लियस के बीच में इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन होगा, विच इज गिवन बाय द रिलेशन minus ze square by r square. Now, for an atom to be stable, there must be an equal centrifugal force which is acting over this electron, and this centrifugal force is acting away from the nucleus, whereas electrostatic force is attracting towards the nucleus. The centrifugal is acting in the opposite direction and it is moving away from the nucleus. So the value of the centrifugal force here is minus mv square by r, where m is the mass of an electron and r is the radius of this orbit. Now, in any stationary orbit, these two forces must be equal. So by equating these two values, we get minus ze square by r square is equal to mv square by r. So minus minus sign cancel out, r cancel out. So finally we are getting here ze square by r is equal to mv square. Now, according to a Bohr postulates, that is angular momentum, mvr is quantized and it is given by the relation nh over 2 pi. So by taking mr over this side, we get v is equal to nh 2 pi m. Now squaring both sides, we get v square is equal to n square h square 4 pi square m square. R is also present here, mvr, m v here, so r will also come in the expression, this r square here. So now substituting this value here, we get ze square by r is equal to m. V square value is n square h square 4 pi square m square r square. Now cancelling the same thing, m to m is cancel here, r to r will cancel here. Now moving this r to upper side, we get r is equal to n square h square 4 pi square m ze square. So this is the relation here, r is equal to n square h square 4 pi square m ze square. We have just equated, or we can say just what we have done till now. First of all, equating the electrostatic force of attraction with the centrifugal force of attraction, then we get the expression for mv square. Then using the postulate of Bohr model of an atom, that is mvr is equal to nh by 2 pi, getting the value of v square and putting this value here, we get the expression for r here. Now in all these value, h is constant here, pi is constant here, then m is constant here, e is constant here, only z and n value can be differ from atom to atom. So what will be the final relation for any nth orbit? Rn comes to be n square, and what is left here? Z, and the total expression for this here is 0.529 angstrom. Now as we know, this h is a Planck's constant, pi is also constant, mass of electron is a constant, E is electron charge. While placing all these values, we get an expression Rn is equal to n square by z into 0.529 angstrom. So this is the relation for the nth orbit. Rn is equal to n square into 0.529 angstrom. Now by z, if we are taking it for hydrogen atom, then value of n will be 1, z also 1. So now the Bohr radius will become 0.529. So Rn will become 0.529 angstrom. By just moving to place here, we get the value 52.9 picometer. That is the Bohr radius of an atom for n is equal to 1, z is equal to 1. That is the first orbit of hydrogen. We get this value. So this is a total expression for finding out the radius of an orbit, and this is also known as a Bohr radius. And so we can say the value of n is directly proportional to the radius of orbit. If n increases, radius of orbit also increases.